The next part of the podcast is about calculating acceleration. So acceleration probably to you means a speeding up of velocity or something speeding up. It could be deceleration as well, which is a slowing down. And that means that you have an acceleration value which is negative. So when we calculate acceleration, we calculate change in velocity divided by the time taken. Now we've written it down in symbol form, v minus u divided by t. I'll just scan in a wee bit so you can see that better. Now I'm just going to define v and u for you because we do use this for the equations of motion, which will be coming up shortly. So u is the initial velocity. V is the final velocity. And I'm not going to write down t because you know t is time. So you have to have your final velocity take away your initial velocity over your time. And that's how you get your answer for acceleration. If your object's slowing down to rest, your final velocity will be 0. So you'll be doing a sum 0 minus a number, and that will give you a negative value in the top, and it gives you a negative answer. And therefore that's a deceleration. So what's that measured in? Well, we know velocity is measured in meters per second. And we know time is measured in seconds. So it's meters per second over seconds. And we say that's meters per second squared. And I'm just going to write in here, deceleration has a negative acceleration value. So this is a question, and this, I suppose, is connected to acceleration in that, well, you'll see when we get to the answer. A lorry has an oil leak which makes a drop fall every second. When the lorry moves along a straight road, it leaves a pattern as shown below. Now you can see at the very beginning of the motion, those wee dots are close together, and I'll just scan in a wee bit till you see there. They're quite close together at the beginning, but as the lorry moves along, you can see the distances are getting greater and greater. And then along here somewhere, I'll just check this with a ruler, but you should maybe be able to see there that those distances are kind of equal along here. So it's starting off slowly because the dots are close together. It's speeding up or accelerating, and then it has got a constant speed here, somewhere along here, and I'll just scan out again. So which one of these answers could describe the motion of our lorry? So it's not a constant speed. Yes, it has an increasing speed, but it doesn't stay at an increasing speed. Eventually these dots get equal distances apart. So that rules out A, B and C. Definitely D is also ruled out. It's not decreasing, it's definitely increasing as the dots do get further apart. And so the answer there must be E. An increasing speed, I should have written speeding up there, followed by a constant speed. So there's acceleration in there. So a couple of acceleration questions. We'll just write the formula at the top here just to remind us, v minus u over t. It says a car changes its velocity. So we are being told what v minus u is there, and I just write it down. That's the change in velocity is 30, and the time is 5. So write down your equation, v minus u divided by t. V minus u is 30, t is 5, and the answer is 6. And the unit, of course, is meters per second squared. A bike starts from rest and accelerates to 20 meters per second over a period of 6 seconds. What is its acceleration? So we're going to go to see what we need here. From rest, its initial velocity must be 0. Accelerates to 20. Its final velocity is 20. And the time taken is 6 seconds. So you write down your equation, v minus u divided by t. That's equal to 20 minus 0 divided by 6. And 6 into 20 goes 3 and a third, or 3 point dot meters per second. 3.3 dot meters per second squared. A few more acceleration questions. A man moving at a speed of 2 meters per second. He then accelerates, so this is going to be our initial velocity, originally moving at 2. He accelerates at a rate of 3 meters per second squared. Now, if you weren't sure this was an acceleration, look at the unit and you can see the seconds squared there. So A equals 3. And for a time of 2.5 seconds. What is the new velocity of the man? So we're looking for V. So A is equal to V minus 2 over the times 2.5 seconds. So therefore 3 is equal to V minus 2 over 2.5. And then to get this an answer, it's 3 times 2.5 is equal to V minus 2. And 3 2.5s gives you 7.5, and I'll just check that. 3 by 2.5 gives you 7.5. And to get V in its own, we have to bring the 2 over here and add it. So V is 9.5 meters per second. And that's the new speed. A car decelerates from 60 to 20, so its initial velocity U is equal to 60. Its final velocity V is equal to 20. It has a rate of minus 5, so the acceleration or deceleration word isn't beside this, it just says rate, but it does give you a unit. And so you know that A is equal to minus 5. How long? We're looking for a time. So A is equal to V minus U divided by T. V minus U then, we'll just put in the numbers. Minus 5 is equal to 20 minus 60 over T. So we're saying then that minus 5 is equal to 20 take away 60 is minus 40 over T. And to get an answer for T, we have to divide each side by minus 5. And so we end up with T is equal to minus 40 over minus 5. And that goes in 8 times. So the answer is 8 seconds. T is equal to 8 seconds. So that's a fairly complicated question there. Not that it's so complicated, it's good for you to recognise what U and V are, what A is, and then you have to do a bit of rearrangement, which might give you a little bit of difficulty. But even if you got this far and said, right, what's 40 divided by something to give me 5? And T must be 8 then.